Okay. Hey, everybody, welcome back. Here we are in session four of the Joy of Coding here at Portland State University. So we're getting into the class. Tonight we're going to do some more test-driven development. We're going to see another kind of automated testing called integration testing. And we're going to talk about the first phase of the project. So you've got the koans assignment, which is due, let's see here, a week from tonight. So I hope you're well into it by now, getting things done. Uh, and because things are going to start to heat up a little bit. So tonight we're assigning project one. We'll talk about that. And then on Monday, I'll assign project two. I sort of want to get it out there so you can be thinking about it, so you can know what's coming next. Because next Wednesday, a week from tonight, we're going to do our first pair programming experience. I want to be able to dedicate the entire class to that. So that's the only thing lined up there. And so then that's why I'll be assigning project two. Usually projects are assigned on Monday, and that gives us lots of time on Wednesday to really focus on in-class activities and dive into certain topics and stuff. Um, but let's start out with anything that's on your mind. Anything that you'd like me to know, either observations and feedback that you have on what you've seen so far, any questions about the topics that we've covered, or the project, the koans, or TDD, or any ideas that you have for what we covered, anything you'd like to see, or want to make sure that I convey or that we talk about. Everybody good? It's okay. Nothing wrong with that. Okay. Awesome. I've gotten used to awkward silence. It's not so awkward anymore. It's just silence. Okay. So then let's dive into it. We got lots of good stuff to cover. So, actually, I want to come back to this handout and I'll post it here in the Zoom chat so that people can play along. We will be populating some more of this, but I want to just review what we did last time. So I'm gonna make this a little bit wider, a little bit bigger. Let me get that off the screen. So, to help us understand, to help us explore test-driven development, we were collaborating together on test cases and then doing TDD for this very simple student class, student project. Um, and here we have one class called student. It's got a main method. It started out with a constructor. It's got some methods that aren't implemented yet, and we started implementing it using test-driven development based on these given when then behavioral scenario descriptions that you all brainstormed. And so then, as a reminder, given when then is a structure that I found very helpful for describing expected behavior of a system, of a program, of a class. And the whole idea is that with given, here, let's talk about the three aspects of it. Where given is sort of the initial context. So it's like, hey, starting here, when I perform some operation, when I exercise some behavior that really is the scenario, then there's some expected outcome happens. Um, and really, I found this to be a very powerful concept, applicable in all sorts of situations, to express an expectation. And this is a really important thing to do because by expressing an expectation, by codifying it in either written language or a unit test, you now have something that everybody can point to and say, "Oh yeah, that's what I expect to happen," and that's a very powerful thing. Anyway, so we use this given when then to brainstorm some scenarios and basically inputs and outputs of interacting with the student class, which basically took the form of constructing or attempting to construct a student class, performing some operation on it, like its toString or its says method, and then specifying what the expected results were. And then we did test-driven development using the red-green refactor cycle. where we start off by writing a test that fails and we watch it fail. So we make sure that the code actually does what we expect in that it fails the first time. That's the red phase. Then we go to the green phase where we implement the production code, the code that's under test, to make the test pass. And part of the discipline of test-driven development is only implementing just enough production code so that the test pass and no more. And what this allows you to do is ensure that you have complete test coverage, because the only time you'd ever write production code is to make a test pass. That means that you've got to write the test first before you write the production code. And by doing that, then you end up with a very robust suite of tests that will validate that your code continues to work as you make changes, such as refactorings. And refactoring is all about taking the code that you've already written and improving it internally by removing duplicate code, by renaming things, maybe moving code around, and taking large methods and extracting them into smaller methods to make the code easier to read and reason about, things like that. And then you continue in this red-green refactor phase until you can't think of any more tests to write. And that really is the ultimate measurement of test-driven development. You are done when you can't think of any more tests to write, and all of your code's been refactored. You're done. Declare success and then walk away and actually give it to someone else to use, and for them to try out too. So that's a quick. Oh, and then what we actually did, we then went over to our let's see here. I guess this would be it. Yep, our summer 2026. So I've been working on the koans. If we look at the student test, we used IntelliJ here to write some tests, some unit tests. So this is the JUnit framework, which hope everybody watched the lecture about, to specify unit tests. And a unit test is meant to be just testing a unit, a program unit, like a class and the methods of that class. And to specify, unit tests using JUnit, and then using the Hamcrest library to have more fluent assertion methods that then assert, which is the when clause. Sorry, yeah, the given when then the then clause of the of the behavior to then validate what we expect. So for instance, to validate that all students say this class is too much work, we create just some student and then assert that their says method returns a value that is equal to the string this class is too much work. So that was a quick review of what we did on Monday. I want to implement another test to sort of remind everybody what that looks like. But before I do, is there anything people would like me to expand upon? Anything that that I just reviewed now that maybe brought up a question in your mind, or made you think of something that you'd like to discuss? And actually, it was really effective a couple minutes ago when everybody sort of gave a thumbs up if you're like, keep going, Dave. And so I'd appreciate that kind of feedback. That way I know people are engaged. So Ollie gave me a thumbs down. How should I interpret that? All good. Excellent. Great. So, yep, we'll go on. Okay, cool. Adam, got anything? You good? Okay, excellent. Let's do it then. Okay. So, let's write another test. We had the last test that we wrote was about a negative GPA. Um, as you may recall, let's see here. Ultimately, we want to have a two-string return. This big old sentence that actually two sentences that describe the student itself, and then have a little statement about what they say. Um, I think what we've implemented right now is just up through the GPA. And now I want to I want to just implement the part that prints out like how many classes the student is taking. So I'm going to do that. Oops. I'm just going to say void toString contains the number of classes. Let's see here. Well, let's start with that, but I want to create a a new student. Great, great, great. And here I want to specify, well, actually, I guess do empty because zero classes contains the number of classes. Yeah, it contains zero classes. Actually, I think that then this also serves as validating that zero classes are allowed, which they are. Okay, that is not what I wanted, but it did help me get started. So let's see here. I really want, let's see here, and is taking and so instead of three classes, and is taking zero classes. And is taking zero classes. Okay. So I'm going to run this. I expect it to fail. And that is true. So it's giving me an assertion error because an assertion failed. And it said expected a string containing and is taking zero classes, but instead the string was name has a GPA of 3.64. Okay. So this is good. This is what I expect to have happen when it fails. And so now let's navigate to the toString method, which I can do by saying go to oops, not type declaration. Sorry. Go to declaration or usages. Here's the toString method of student, and now I want to augment it with has a GPA. Is it still my clipboard? Yeah, great. So I have three classes. Now this is an interesting thing. So right now, this is we basically want to have this number be the number of classes that are taken. Now, as you may recall, Uncle Bob, in his video, when it was, I think it was like when he had like the bowling score, he hard coded the a return value to like -1 saw it fail, and then had it return zero, which made the test fail. And if we had sort of gone further in that video, you'd see that as the bowling game got more interesting, he would have had to change that. So what I'm wrestling with right here is whether or not I should just hard code this to zero to make it pass, or and then and make it pass, which might be the more like sort of pure way of doing it, because now that allows me to write a unit test that specifies one, like two classes, and then I would see it fail first. Um, I'm going to do that in this case. It seems a little pedantic, maybe, but I think it helps reinforce sort of the red-green refactor cycle. So, like for instance, I just made this green. This is cool. It works. And now I want to write another test. So I'm just going to duplicate that code right there. And then I'm going to say, contains two classes. And now here, to make it, I want to introduce a variable here because I got to add two items to it. So I'm going to say, oops, I'm going to say extract variable classes. Great. And so I'm going to say, sure, algorithms and operating system. That's a wonderful couple of classes. And so this should say taking two classes now. So I'm going to run this one, and it's going to fail because it's hard coded zero. So I was expecting, it's taking two classes and it's taking zero classes. And now I've got to implement it all the way. So now I can navigate to toString. And instead of zero here, I want to have the number of classes. And any recommendations on how I implement this? Any thoughts? Yep. Yeah.
Or less than zero.
Yes.
So where do you see the data number strengths?
Well, that's a great question. So yeah, I mean, Adam's pointing out, I was like, oh, listen, we want this to be a number right here. Is there a situation where it can ever be -1, for instance? That would be something. And the answer is, well, no, not really, because what gets in for where this ultimately comes from is the number of classes, which is the size of the array list which is passed in. So it's the size of this array list right here. You can't have an array list of the size of -1. So you need to worry about -1. And we've already agreed that 0 is okay. So we know that the number of classes, as long as it is the number of, the size of this array list, is always going to be 0 or greater. That's good. Um, so then I think ultimately what we want to do with the array list, though, is something similar to what we did with the GPA, which, as you may recall, we ended up adding like the this.gpa field. And so we'll say this.classes. And this field doesn't exist yet. And that's fine. And so I think I'm going to do the following. Go up here to my constructors where we pass in classes. And as we learned last time, we'll need to assign it to a field. And I'm pretty sure that if you use Option Enter to give some options, we can create a field for classes. This is a nice little shortcut in IntelliJ. It'll take a parameter for your constructor method and create a field for it. It's a very common thing to do. It's an array list called classes. That's great. And as you can see, it is assigned here. And now down in our toString method, let's go down to toString. Oh, right there, this dot classes is already there. So I think this is going to work. Oh, sorry, not this dot classes. This dot classes, well, if we leave it like this, actually, I want to show you what it does. I appended this dot classes to this string, and actually what that did was it printed out the contents of the array list. We don't want that. We want the size of the array list. Nice. It passes now. And now I want to rerun all of my tests, which I think I can just do from here. If I right click, I can say run the entirety of student test. Yep. And now everything passes. That's good. I'm going to turn off the individual ones. We can see that all of them pass. So that's just a reminder of the red-green refactor cycle, right? We start out by writing a test that fails. We see it fail. We then write a test to make it pass. And then we look for opportunities to refactor. I don't really see anything. Does anybody else see an opportunity to refactor either the test code or the production code here? Nope. Sorry, what? Oh, like yeah, enforcing like the GPA. Yeah. Oh, good. Yeah, good point. So yeah, right. I mean, Adam was just saying, hey, let's, more test cases that we could write would really be enforcing the properties of a GPA. Now we already throw an invalid GPA section exception if it's less than 0. Is there an upper bound on a GPA? I think there was a scenario that says that there was. Yeah, like if you have this one right here, it says that if you have a GPA of 5, you should also get an invalid, it's off the screen, also get a an exception. So yeah, let's implement that. We can do that real quick, but let's do that separately from these other ones that we did. So include the number of classes in the student string. Oh, sorry, I'm using keyboard shortcuts. Let me know if I'm going too fast. Now let's see here. We had this one test, which is negative GPA, throws an invalid range exception. And so now I'm going to make a copy of that. And I'm going to say what? GPA greater than 4? 4.0. Throws invalid range exception. Does that sound right? So an invalid, so like if it's 4.1. And again, we use this assert throws to basically say, hey, listen, this code that we're creating right here with this was called a lambda function or a lambda. Lambda expression maybe is the right word for it. When I go to create a student with this invalid GPA, I expect that it throws an invalid GPA exception. If it does not, then the test will fail. If it does, then that exception that was thrown will be returned and we can interrogate it and assert that the invalid GPA associated with that exception is indeed the invalid GPA that we sent in. So I run this. It fails as expected because expected invalid GPA exception to be thrown, but nothing was thrown. Well, and why is that? Well, because we never checked for it. So we should say something like if GPA is less than 0 or GPA is greater than 4.0, then throw the invalid GPA exception. And it'll include the GPA in both of them. And I think that means it'll pass. And it does. Yep. So that's checking the range. Now, you also mentioned a test case where it's like, hey, what if like, the string value of your GPA is like some crazy big number or what, or rather has a ton of digits, a ton of decimal digits, you mean? Yeah. Interestingly enough, because the GPA is represented as a double, we can't write that test case, right? Because here, what comes into the student constructor is always going to be a little d double. So I suppose we could have like what, just like a double here or something like that.
You could have, I guess it's just 64 bits, but I guess you could, here, just try double dot min, see what that prints out.
Oh, sure. Yeah. Now what I expect it to do is because double dot min is less than 0, it would get uh, the invalid GPA exception. So we can certainly write that test. Yep, definitely less than 0. Yeah. So where I'm going though is sort of reinforcing that for the unit test, the GPA is always a double, a little d-double value, and you can't have like an arbitrary string or any string be that value. However, I think it's a nice segue to where I want to go next, which is focusing on the command line. And on the command line, the GPA is passed in as a string because everything passed in on the command line is a string. So while I'm committing this, though, are there any other topics people would like to bring up? Anything sort of related to unit testing or working with the string class that's on people's minds or that they'd like to discuss?
Guess the maximum is 24 characters long.
Okay, interesting. Um,
17 decimal digits of precision.
okay, well, probably there at some point you get like, I mean, I don't even know if that does that compile even. Maybe it does. I have no idea.
Maybe 17 launch.
It looks like it just compile. That's longer than 17. Yeah, so I guess that compiles.
I'm actually curious what your string looks like now.
Yeah, me too. Um,
Just trying to think of interesting cases.
yep. Well, we're good, right? Uh,
Thinking about, well, could I have memory inject with a hexadecimal?
nice. Well, actually, and let's get back to that though, as we're talking about the command line, and how to test the command line. So so far we've been focusing in on just the student class itself, and not just the student class, on the instance methods of the student class. There's also this main method. And recall what the main method is. This is where program execution starts when it's when the program is invoked from the command line. So we had this command that was java-jar, which runs the executable jar. We talked about that a bit on Monday. And when you give the name of the student jar file, then that runs the main method, right? It prints this missing required student information, which is what is printed by the main method. But ultimately, this isn't what we want. What we want is to have the command line take in these arguments and then create a student from those arguments and then print out the toString of the student. And so to help inform how we implement that, let's brainstorm some additional scenarios, which are all about invoking the student the student command line program, so the main method. So instead of focusing on the the instance method of the student, this is really looking at the program as a whole. And here's not much of a given. I mean, given, hey, we built the executable jar file. We can talk about when certain program arguments are provided. Then we see the following on standard output and standard error. So for instance, this happy case, when you provide Dave Mail 3.64 algorithms operating system Java on the command line, then standard output has the two string that Dave has GPA 3.64, taking three classes, et cetera, and nothing is printed to standard output. Sorry, standard error. The thing I want to highlight here is that, this is the inputs and outputs to the program. The inputs are only on the command line, and the outputs are either standard output or standard error. That's all you get from a command line. We don't work with standard input in this class. That seems a little too much like CS 101 to me. Java has support for standard input. Don't get me wrong, but we're just going to provide command line arguments here. They're easier to deal with and works better on Windows and things like that.
Can you drop?
Oh yeah, sure, totally. Yeah. Okay. So let's see here. Let's brainstorm some scenarios here. Let's not take the time to go into a breakout room or whatever. Um, but let's just take, I don't know, 3 minutes and just work quietly on our own, and then we'll take another 3 minutes to talk through some of the scenarios. Okay, that was some good brainstorming. So let's see what folks came up with. So let's see here. Yes, a very, very small number. And so then here, yep, we're going to look at having a yep, does that then get printed as just two decimal places. Nice. Yep, another good one, making sure that when there's a negative number on the command line, that it is indeed an invalid GPA. Um, let's see here. Oh yeah, yeah. This is interesting. Yeah, we escaped some double quotes there. We want to make sure that that is here. Although, see here, Adam, was this yours? You're asking what is a valid class name? Yeah, no, I think that's a really great question. That's the thing I love about these behavior scenarios. They really make you think about what what the shape of the data should be. What is out of bounds, what's inbounds, what's okay. Honestly, I don't think I have any restrictions on the name of the class, right? I mean, you could call it an emoji symbol if you want. I don't care, right? Um, so then, yeah, that's good though, right? You're making sure that there are some what appear to be exceptional names in the on the class for the classes. Oh, this is a good one. Yep, missing. Well, actually, this is interesting. No classes provided. Now, I think we said it was okay to be taking zero classes. So then, is this valid or is it not? But I like what you're testing here, right? So that's like missing command line arguments. I think that's important to be able to, think about those kind of test cases. So yeah, I would recommend just turning if what we want to if what we want to test here is that there's a command line argument missing, they should probably get rid of the GPA and have this be missing GPA or something like that. Adam, what do you think? Would that be an okay mod? I think this was yours also, right? Is this be an okay modification here? Okay, what was your intent of number five here to test what happens when there are command line arguments that are missing?
Yeah, that one was mine.
Oh, was there? Okay, awesome.
Yeah.
Thanks, Sid. Yeah, I like that. So I think here there's nothing printed to standard output because there's not a valid student, but instead, yeah, saying missing GPA or something like that. Nice.
Okay. Thank you.
Oh, that's good. And let's see here. This one here, this might have been Yasmin's. Yeah, duplicate courses are not allowed. Cool. That sounds good. Yeah, I like that. Nice. Okay, that gives us a good place to start. You know what I'm gonna do? I want to see. I've never done this before. I'm gonna try it. I want to see how what Copilot does. I'm gonna fire up Copilot. I might do it in a separate shell. I like to do things in separate shells with Copilot. PSU get it will join for coding December 2026. I'll launch Copilot. Gotta make it a little bigger. Yeah. Okay. I'm working with some students to implement the project specified in this PDF. And I wonder if it'll see it all. Um, can you view that document? Yes. Go ahead, download stuff. And do I run that command? Sure, run some Python. Yeah, and fine. And go ahead, run some more Python.
Do you prefer the CLI?
I do. Yeah. Um, okay, neat. Great. Okay. Good. Okay, great. We're brainstorming test scenarios for the command line program. The command line takes information about a student as program arguments and prints out information about, prints out toString. Maybe he knows that. The toString if those arguments represent a valid student, otherwise an error message. Let's print it out. We started brainstorming ideas I want to see if I can read the Google Doc. In the section of that, can you read the table with the, was it the when and then headings? Oh, interesting. Nice. Okay, great. Can you please make some suggestions. Please make some suggestions for additional when and then scenarios. Great. Yeah. Let's see what it says. Because maybe you can think of things that are better. Oh, look at this. Very nice. Okay, so let's read this over. Oops, scrolled a little too fast. So what is it saying? Okay. Yep, okay, valid GPAs outside of the bounds. Oh, GPA must be a number. This is good. Yep, 0 classes. Okay, very nice. Interesting, missing name. So when it's an empty string, it says it's missing, which we didn't really determine whether or not an empty string is a valid name. I actually think there was a test case where it said it wasn't, so I think that's okay. Yep, missing oh well, this is interesting. So this is missing gender as opposed to, yeah, that's an interesting one to try to determine. And it says missing GPA. So yeah, I don't know how you determine that, because I would say that this is an invalid GPA, because I would think that parameter argument three would always be a GPA, but whatever. Um, great. Oh yeah, unknown and they. Very nice. Case insensitive. Yep. Again, very nice. Class names can't be empty. Yeah, that's a good one. Duplicate courses are not allowed. We already got, oh, case insensitive. Well, we didn't really talk about the case um of the class name. Good stuff, good stuff. And then one class. Okay, that's good. And then zero GPA, zero classes. Okay, that's good. If you're especially valuable edge cases side of the group, right. There are no class provide. Yeah, should be case insensitive. And the answer is yes, if you read the program, if you read the PDF closely. Didn't say anything about duplicate classes. And then, oh yeah, right. Should GPA always be two decimal places? And then, right, yeah. So if it's an unknown gender, uh, should reject them, allow them, or use they, them. Great. Okay. And that was specified in the PDF also. So I guess I didn't read the PDF very closely, but this is a good place to start. This is what I like about Copilot, or and the AI assisted tools. It's not so much about doing the work for me, but it is like telling me the things that I missed, or after I understand the problem a little bit, tell me what else I need to know about it. So yeah, cool. Anyway, I just wanted to show that off to give us some more ideas. So that we've had some time to brainstorm on our own using our human brains, and we've used the electronic brain. Are there any other scenarios or anything else about the how the command line works that we should discuss before we start writing tests for some of these and doing some TDD for the command line?
Buffer overflow or
Buffer. How would you get a? Okay, yeah, great. How would you get a buffer overflow? Like, what buffer would you overflow? Like the number of stuff in the command line.
processing, CRM, standard in, and then, like they, just in case, clear the buffer before you take another CLI argument. And
Hmm. And like, how would you express that as like a test with like this input and these outputs? Yeah, right. Yeah, yeah, right. Yeah, it's good to consider these things. And then what I always ask myself is like, well, how do I reproduce that? Like, how would I express that? And in Java, you don't have the same kind of like you don't there aren't language mechanisms that allow for buffer overflows because if you try to index beyond the end of an array, you get a runtime exception. It's not like you go off and reference some piece of memory. It's only if you like dive down to native code they have to worry about that, and so then it's not never an issue, but it's just very, very, very unlikely. Um, yeah, and on the command line, then you kind of like, yeah, maybe there's not, okay. Anyway, but good idea. I don't know. I don't know if we can write a test for it though. Well, we're not reading from system in, luckily, right? We're just reading from the command line. No, it's got some, yeah, non-ASCII characters, kitty cats.
guy. String.
Okay. Yeah, 3 GB string. Actually, what do we even, yeah, like use xargs or something to like put it on the command line? I think we're talking about some boundary conditions and probably not things that we don't enforce inside the program. So I think that's good to be that creative, but um, let's put that aside for a moment. Let's focus on some of these, and we'll maybe come back to that once we've developed more of the code, and so we have more stuff to exercise. Oh, here we go. I'll add something. What about multiple empty arguments, like just a space entered? Oh, nice. Okay. Yeah. So if all we had was a space here, what would we expect the program output to be? Missing required fields and less fields. Oh yeah, I like that. Yeah. So yeah, we could say something like missing. Ideally, we'd say missing gender, right? Because that's the first one that's missing. But yeah, I suppose we could say gender, GPA, and classes, or gender and GPA. definitely missing gender. Yeah, and then printing out the required fields. Yeah, that's good. We'll come back to that printing out the required fields part of it when we talk about the assignment. But yeah, I like that. That's a great test case. Nice. Okay, so we got some scenarios here in the doc. We got a Copilot that helped us out with some. We can come back to those too if it makes sense to do so. Now that we've brainstormed these scenarios, let's talk about how to implement them. Let's talk about how to write automated tests that validate the main method. Now, invoking the main method is different than invoking other methods because the outputs aren't like a return value. It's what's written to standard output and standard error. And so if you're just calling the main method, right? So we go and look at the code. We go to the student class, the main method. Well, this like prints something to standard error. Um, how do we write a test that validates that text was written to standard error? And therein lies one of the challenges with testing the main method. So I now want to turn to the discussion of unit tests versus integration tests. So I mentioned this briefly last time. I will go into it in more detail now. When it comes to automated tests, the intention their unit tests are something called integration tests also. The intent is that a unit test is focused and small and runs very, very quickly. The idea that, hey, you can run all of your unit tests in like under a minute, or in terms of the ratio of amount of code to the time it takes to run the test, it's a very small amount of code for a very small amount of test time running time for a lot of code. And so then, there are some kind of classic definitions of something that's not a unit test. I'm sure Michael Feathers was doing some stand-up comedian, kind of Connie said, you might not be a unit test if. So, like if it talks to a database, if it requires a database, too slow to be a unit test. You got to start the database and query it. Talks to a network, if it accesses the file system. If it can't be run in parallel, so meaning that like it's dependent on certain tests also, running at the same or not running at the same time, or maybe the order of things. It's not really a unit test. Or if it just requires something special, like special configuration or whatever, it's too complex to be considered a unit test. Doesn't mean it's bad. And as a matter of fact, you do need to test all this stuff, right? You do need to make sure that your code works with a database. You need to make sure that if it's got some REST API or something like that, yep, it does work. It just doesn't mean that it's a unit test. Um, and so your unit tests are all about working with the fundamental building blocks of your program. The classes, the objects, the methods, right? It's very code centered where you're testing is code. But that, you can only go so much. And when you need to test multiple components, that's when you need something more complex. And that's when you need an integration test. And so integration tests are all about the interaction between multiple software components. Those can sometimes be, components within the same program if you've got two big subsystems or whatever, but more likely it's something that is external. Again, a database, a REST API, things like that. And then as a result, integration tests are supposed to be slower, and you don't run them nearly as often as you do your unit tests. So, maybe you, as you're, doing a TDD cycle, as we've seen, we run the unit test multiple times as we are, writing something a failing test and writing, code to make it pass. And then we can go through and run our entire suite, often to make sure things work. Integration tests, maybe you run like, I don't know, once an hour, once every couple of commits or something like that. Because they're meant to provide a more holistic sanity check or smoke test of more complex functionality. And so, for instance, in our student class, we can work with the student class's constructor and the two methods, the says and the toString. That's all good unit test stuff. And that's what we did last week in the beginning of class tonight. We wrote some very simple unit tests to validate the inputs that go into the constructor and the outputs that are returned by the says and toString methods. But the main method, though, it is more complex. It takes input from the command line. It writes to standard output and standard error. How do you test that? In addition to, and I guess the main method also works with student class, but it takes its input and sends its output to more complex places. And so then when when testing things with the command line environment, these are integration tests. These are more complex tests. In addition, it's you have to go to some acrobatics to do things like capture what is written to standard output and standard error. And so for this course, I wrote a little framework that does capture standard output and standard error from a main method when it's invoked. And we in a little framework called invoke main test case that is used by the integration tests like student IT. So IT here stands for integration tests. And this, it still uses JUnit to run the tests, but it does some, but it then uses that invoke main test case to capture standard to invoke the main method and then capture standard output and standard error. So as you may recall, when we first looked at the code, there were three kinds of Java code. There was the production code, which is here in the source directory, sorry, in the source main directory. There was the unit test code that was in the source test directory. And there's also the integration test, which is in source IT. And each of them have a Java directory and then all the directories required for your Java package, and then a class. So here there's a student IT, which is the student integration test. This invokes main test case, which then gives you this invoke main method that you inherit. And invoke main, well, invokes the main method on a given class, and we press in that class using this .class notation, and this will invoke main. As a matter of fact, this method also has a variable length number of arguments that'll be sent to the command line, and we'll see that in a moment. So this invoke main method will invoke the main method of student and return this object of type main method result called result. And it gives you the ability to get the text written to standard output, or in this case, standard error. And then you can use, and it gives it as a string, returns it as a string. And then you can use that with a hamcrest assertion, just like we have with any other method call. And so we can say that, hey, the string returned by get text is written to standard error contains missing required student information, which is exactly, what it does. And so when we run this, and we can run it just like in any other JUnit test, because it is a JUnit test, yay, it passes. We could also add another assertion here, written to standard output, standard out. And then let's see here. Is there an is empty string? Oops. Uh, is empty string? Oh yeah, there's one. Great, from Hamcrest. Deprecated, apparently. Interesting. So what should I be using instead? It doesn't tell me. But let me download the sources. Is deprecated use is empty string instead. Okay. Close that. I can say is empty string from Hamcrest. And then some of these. Yes. Nice. And so now when I run this again, that should pass, right? Because it is empty. Yep, nice. So this is how you use this result, this main method result object. You can get the text that was written to standard error, get the text that was written to standard output, and then you can just, assert information about them. And this is basically how we will write the how we will write the our integration tests. We will invoke the main with some number of arguments, and then we will assert information. We will assert that certain information is written to standard output and standard error. Before I dive into some examples, though, are there any fundamental questions that I can answer for folks with regards to integration tests, what they're all about, or how to write them using the invoke main test case class?
Can you open the invoke main implementation?
Yeah. Do you want to see how it's implemented?
Yes.
Okay. basically I'll tell you about it and then you can go and dive on your own. But it uses this API, so it passes in a class, which is I think you've seen this in the koans. This is an object that represents a class in Java, and there is a way to actually, if I just like go in here, yeah, you can use this so the main class, the class object, you can get its method, a method called main that takes an array of strings and the code isn't very well formatted. And then let's see, here's that main method. Then we go down here. We um we basically replace standard output and standard error with an object that will basically record what's ever written there. We'll write it to a byte stream, a stream of bytes. We invoke the main method, and then we go get the string value of what was written to standard output and standard error, and we assign it into the result. And that's kind of it. And there's a bunch more details, but yeah. So a little bit of magic, using, APIs like, set out and set error, as well as the reflection API to invoke it. But yeah, that's the way it works. So let's dive into some test cases. Um, I kind of like this one first. I think this one sort of seems like the simplest one. So, well, actually, I suppose the simplest one would be like no command line arguments. And so then this would be like missing student name. Now we're just missing name. That'd be the easiest one. Which actually, yeah, we've kind of already got. So, this test is no longer valid. Well, actually, no, I guess it kind of is. Missing required arguments. Okay, actually, no, never mind. That's what it should do. Or no, we can change to say missing name. Let's do that. Missing name. So we'll change it here and then we'll run it again. We'll see it fail. And so then we'll go back over to the main method and we'll say missing name. Nice, easy peasy. Okay, now let's have a name, but missing this is the gender is the next one. So missing gender. And well, I'm just going to copy this to make it a little easier. So here, the way it works is if we want to provide command line arguments, we do so in a variable. We can have multiple arguments like that. We're just going to have one. Nope. And now we're going to say missing gender and nothing written to standard output. So we're doing the same thing as if we were, oops, from over here with name. So that's basically this. Oh, by the way, when I run this, it's still printing out the old message because I haven't rebuilt. So I can do Maven W. I can run the package phase, which will. Oh, this probably won't work because the unit test will fail. Oh, it did. I'm surprised. Really? Because that should fail. Did it not run the unit tests? Student. Oh, no, right, it's an integration test. Yeah, yeah, it doesn't run the integration test yet. Okay, cool. So I went in and I ran the package phase, which will rebuild the jar file. I run the unit tests. The unit tests still pass, but it doesn't run the integration test. The integration tests run after the package phase. I created the package again, and now when I run the jar file, yep, it says missing name. Oh yeah, it says missing name because because we'll see. Expected missing gender, but was missing name, and the reason is that it's always missing the name. So now what we need to do is we need to start parsing our command line. Um, Spoiler alert for project one, what you'll be doing in project one is parsing the command line. That's the primary part of the project. So we'll yeah. So we're going to see how to do that now. So let's see here. We want to say the following. If there aren't any command line, it doesn't equal one. No, I'm going to say if it equals zero, then I'm going to print missing name, and I'm going to return. Stop it, you. Otherwise, oh, why is that underlined in gray? If statement can be collapsed. Yeah, I'm sure it can. Otherwise, no, actually, otherwise, I'm just going to leave it at this because this ought to make the test pass. Oh, no, no, wait, say missing gender. Um, yeah, right. Because now if I run my test again, it should still fail because it was empty. Right, right, right. So now if it's missing gender, say okay. If args.length is only one, then we'll say missing gender. Try that. Okay, that works. Now I want to go back and run my other integration tests to see if they all pass. Okay, this is neat. Well, since I'm on a roll, let's also do missing GPA. Missing GPA. So it's got a name, it's got a gender, and now missing GPA. We'll run this one. Yep. Nice. Okay. So then now if R only equals 2, missing GPA, yay. Sometimes AI is helpful. That passes. And now all my classes pass. Nice. Okay. Well, that was super easy. But now I've got test cases for all of these. This is good. Okay. Well, gosh. Now, I think I've got enough to construct a valid student, right? I've got enough to then say, yeah, I could create a student now. Let's try it out. So, student taking zero classes is printed to standard output. Standard out. So then we'll do this. And let's see here. Name female, now GPA of 3.45. And then the following. Standard output should be empty. Sorry, standard error should be empty. And now standard output should contain string the following. It should be, let's go back to, I need to just remember what the text is. Yeah, okay. So it should be something like the following. It should be, well, let's put uh, name has a GPA of 3.45 and it's taking zero classes. 3.45 is taking zero classes. That's what I would expect, right, from that input. It should be capital N name. Let's run that. Okay, expected that, but was printed nothing because it doesn't do anything with the student. That's what I expect. It's failing. So let's go back and take a look now. Now we need to now we need to extract information about the student from the command line. So I'll do the following. So the name of the student is the first argument. Equals arg0, gender is 1, GPA. Oh, look at that. It even is even smart enough to figure all that out. Great. Student equals new student. Name, new array list, GPA, gender. Yep, that's all right. Good. And now system.out.println student. Yes. So what are we doing here? Well, we've gotten the name, gender, and GPA from the command line. Let's see here. We're confident we're not going to get any array index out of bounds exception because we've already checked the number of command line arguments. And then we've converted argument 2, which is the GPA string, to a double using double.parseDouble. And so then I believe this was covered in the lecture for tonight, but this is how you convert a string to a little d double in Java. And now we've got all those. We can create our student. Right now we're not worried about classes, and that's fine. The class, we can figure it out soon enough after we write in our test for it. And then we create our student object and we print it out. This looks okay. Does anybody see anything that might give us pause? Test passed. That looks pretty good. I'm going to commit this while I'm doing that. Anything that people like to discuss about what we just saw here with this code?
Arms is not the last.
A last name, say more. That's true. Yes. Let's see here. Well, let's see here. Yeah. So begin command line person. Yeah, I mean, Adam brings up a good point. I guess about last names. And so then, yeah, that is true. The first command line argument is the student's name. So let me actually, while I do that, I think I'm going to run clean verify. So the verify phase of Maven will run the integration test in addition to running everything else up to that point. Oh, something failed. Oh. Oh, very nice. Very nice. I didn't, you know what? I made a mistake. I did not go back and run all of my tests before I committed. So something went wrong. Luckily, I caught that right away. What is it saying? Oh, class not found. Okay. This is when you go back and forth between the command line and IntelliJ, you'll sometimes get this error about could not load class with this test engine with ID JUnit Jupyter. The way that you fix this is by doing a Maven clean. Maven W clean. Maven and IntelliJ can sometimes get in each other's way. That usually clears it up. Let me run those tests again. Oh, good. They ran this time. And now, oh yeah, look at this. Huh. This got an array index out of bounds exception. So this is missing gender. Oh yeah, look at that. These all fail because it gets an array index out of bounds exception here on line 74. And yeah, there's a bug here. Can anybody see the bug? Like what? Why? Yeah, but I have all the checking here, right? I mean, I've already made sure that the length of the array is 3 down here, haven't I?
There, it's the flow control.
Yeah, the answer is no, it doesn't. Just because I print something to standard error doesn't mean that like the program returns. So what I need to do is I need to have return statements after all of these. Oops, it's a bug. But look, it was a bug that was caught like very shortly after I introduced it because I had automated tests. So I didn't mean to do that, but I think I did something that then helps this proves a point where it's like this is why it's good to have automated tests. It told me right away that there was a bug in the program. I wouldn't have caught that otherwise, and it would might have taken a lot longer for us to figure that out later on. So we'll try that again. We'll run the clean verify from the command line. Good. I'll quick check those in. Oops. Forgot to return after error conditions. Okay, I rebuilt the command line and now I can test it a little bit. Missing gender, that's great. I was going to make a point here. Name female 3.45. Yep. So I guess what I wanted to show you is that these integration tests really do the same thing as invoking things on the command line. So like, right here with name female 3.45, I get the same thing. Now, Adam had asked about first and last name. You can have the first argument, the first command line argument is going to be the student's, I guess, full name. The assignment doesn't really talk about first names and last names. So then, the expectation is that if you want to have, um, a word with a space in it, so, first, last, you would surround it with double quotes. And this is just like command line syntax, right? So when passing things on the command line, stuff surrounded in quotes will be passed as one command line argument, right? And so then the name of the student is first space last. But I mean, you're thinking of it as it's a good scenario to think about. It's like, okay, well, how do you provide the name? And then, yep, it would be like this. So that's something that we could, capture on the Google Doc. It's like, great, if you want to have, a name with a space in it, then, you just put it in double quotes. And so it'd be one command line argument. Did that sort of get what you were thinking about?
Yeah.
You seem unimpressed. What?
User error.
No, learning. Yeah, well, okay, there you go. Great. Yeah, and this is how we learn, right? We put ideas out there and we experiment with them and we see what works and what doesn't. That's good stuff. Okay. So let's see here. Where to go from here? Let's go a couple more test cases. Oh, let's see here. We sort of gotten this one already. Oh, duplicate courses. This would be a good one. Um, Actually, before we get to that one, I think I want to do this one with a negative GPA. Yeah. This is a good one. So actually, I'm gonna just copy this here. I'm gonna go back over here and add a new test. Um, let's see here. Negative GPA prints error message or prints message to standard error. Right. Keep it on the clipboard. I'm gonna copy. Well, actually, I'm gonna copy this one because this one has the right error and this somewhere here. Okay, so we're gonna take this and now we're gonna turn that into, oops, one arguments over here. So this will be Dave Mail. Negative 3.64, and then algorithms, comma, operating systems, comma, Java. Oops, it should be a comma, not a dot. Oops, somehow, oh yeah, right. Don't need that anymore. Okay, and let's see here. What should this print out? Valid GPAs are in the range. Yeah, like that. Oops. Where to go? Yeah. Okay. Nice. Okay. So let's see here. What do we think is going to happen here? Any guesses? Ooh, gonna throw the invalid range error. Yeah. I think that's exactly what's going to happen. Yep. So this is a good lesson. Okay. So the test fails with an uncaught exception in main. So for this class, your main method should not throw exceptions. I want your code to handle errors gracefully. And if you are a user and you see some big ugly stack trace, nope, that's not a good user experience. Especially for someone who's not technical, they'll see that and it's like, oh my gosh, I just broke the internet. Right, yeah. So you want to issue a nice error. And so then you want to catch your exceptions. So here, And I tell you this, and right, the invoke main um, framework tells you this by throwing a very special kind of exception when you get an uncaught exception during yeah. So you do get the invalid GPA exception when you call when you create your student. And but this is failing because instead of just throwing an exception and having it spill over into the command line, you want to catch it. And actually, let's go run it from the command line just so that we can see what happens. Actually, let's just go back to the document again. We will copy these arguments. We will send them to the command line. Yeah, that looks good right there. Yep, sure enough, we get this invalid GPA exception. We should not see the stack trace, and we shouldn't see this like exception in thread main either. So instead, what we want to do is we want to handle this better. We want to handle the exception better and print out this valid GPAs are in the range of 0.0 to 4.0. So let's see here. Yeah. So I am going to split declaration and assignment. I am going to wrap this uh, in a try catch. Well, that's all very nice, but that's not the message that I want. Oh, and it even returned. It's learned there. And so then here is the message. Isn't it interesting that like the AI doesn't know about like the test that I'm writing? I could probably tell that I was working on the command line, or maybe if I was using a smarter model. Okay, and I think that's what I want. I want valid GPAs are in the range of this. Yay, that passed. What it suggested to me before is I also print out the GPA that's associated with the exception. I kind of like that. So I'm going to change this message a little bit. I'm going to say invalid GPA, and then E dot get invalid GPA dot space valid GPAs or that. And so then I'm going to change my test. Actually, I'm going to run it and then change my test based on that. Wait, really? What's more with feeling? I wasn't expecting it to pass. Why'd that pass? Oh, haha, because I did contain string of the thing in the part. Yeah. So I want invalid GPA minus 3.64 dot space. I think that's right now. Yes, now that's correct. Good. Yep. Two spaces. Okay. Nice. So here, we want to, in the main method, we want to catch the exception thrown by the student constructor and handle it nicely. Print out an error message, include any information that was there in the exception, and a helpful error message instructing them what the valid GPAs are, and then we're done. We don't want to try to print out the student. As a matter of fact, we can't because the student was never created because an exception was thrown during its constructor. Print a friendly message if the GPA is valid. Okay, and there was one other one. What did I want to shoot? What was I going to do? Huh. There was one other condition I wanted to test. Now I don't remember what it was. It wasn't one of these, was it? Oh yeah, not a number. Right. This is good. So GPA must be a number. So yeah, this is a scenario that I want. Oh, even fills it in there. Yeah. Okay. So then yeah, Dave Mail non-number algorithms. Oops. It doesn't copy and paste very nicely. I would expect it to, I guess. Okay. So let's go. Actually, maybe just yeah, we don't have an invalid GPA, do we? That's fine. Okay. And we'll do the following. So then test invalid, well, not invalid GPA Non-numeric. GPA prints error message standard error. Great. And here we'll just do this. And then we will do non-numeric. And let's see here. What does it suggest for a error message? GPA must be a number. Sure, I like that. Actually, I want to say invalid GPA, not numeric. I like to provide the information back to the user about like what was wrong exactly. And by the way, in project one, one of the things to be graded on is how helpful your error messages are. And I'll provide some examples when we talk about the project, which we will be doing shortly. Okay, so then I'm going to run this. Aha, another uncaught exception because we got a number format exception while parsing our double on line 78. Okay, so we parse our double, and if we aren't able to parse the double because args2 here is that string non-numeric. So now we want to issue a nicer error message. And so we do the same thing. We need to then catch the exception that's thrown when double dot parse double fails. So I'm going to split in declaration of an assignment. I'm going to say try, and here I'm going to catch the number format exception. Yeah, invalid GPA, args2, and then I'm going to put whatever was there in the message. GPA must be a number. And then it returns. Thank you. Okay, the rest of this looks good. Let me run this again. That passed. I'm going to run all of them again to see if all of them still pass. Great. And they do. So, again, I'm doing test-driven development, but now I'm focusing on the main method. And as you can see, the main method has some different concerns than just the plain old unit test, the student constructor. I need to go through my command line argument array and make sure that it's got the right number of elements. I need to worry about converting strings to doubles. And I can use the student constructor, but now I've got to deal with the things that might go wrong with the data passed into the student constructor. Handle an invalid, well, a non-numeric, numeric string. Cool. So, this is integration testing, right? You use this the IT test class, which extends invoke main, which then gives you the invoke main method and the main method result. And then here just the shape of the integration test look a little different because what you're doing is passing in the uh the name of the student class and then the arguments, and then you're asserting that standard output and standard error contain certain values. What do you think? Um, ha have you ever encountered anything like this in any other classes? Sort of like this test-driven development, this test-driven approach, just writing tests for your code. Is this concepts that you've seen before? Oh, yeah. Did you take Chris's? Is it a TDD? Is that what is it? Unit testing and stuff like that?
Class,
Oh,
but
nice.
everything in school is just thrown away. So it's not really.
Oh, say more about thrown away. Oh, I see. Yeah, yeah, yeah.
That's the inability.
Right.
And the instructors and other researchers too, so once their project is over, which is usually one cycle things. So
Gotcha. Well, yeah, okay. Well, so then, okay, good. So Yasmin says that, oh, good. You've seen some testing in 302 and 314. Excellent. Good. So hopefully then these constants aren't entirely foreign to you, but yeah, as you'll see and as we'll talk about here in a little bit, testing is a big part of this class because it's a big part of software development. And and to Adam's point in here, you will be working with the same code base throughout the rest of the course and code base that you've written. And so then hopefully then that gives you an introduction to what it's like to, work with like your same code week after week and go through and evolve things as the requirements evolve, as you learn more. Hope that will make for a valuable experience.
I think the university never prepares the students for how massive the code base is that they'll be working on.
Yeah, and that's a good point. And that's something that I'd like to figure out how to do is to, in a classroom setting, work with a large code base. And now with AI, I think there's certainly a path forward there that seems more practical and more feasible for, undergraduate students in an 8-week summer course being able to, really work with and understand and learn techniques to understand large code base. But that's a conversation for a different time. Okay, then we reach a good time for a break. Let's take 10 minutes. And when we come back, we're going to put down the code for a little bit and we'll start talking about the first project. But first, let's rest our eyes, stretch our legs, and let's take 12 minutes. Let's come back at 7:40. Okay, everybody, welcome back. So, the first part of class, we talked more about test-driven development, but now test-driven development of the command line program. And we saw how to use this invoke main test case class to test the command line program, or the main method of the student class. And we saw how the main method just looks a little different. It's got, logic in there for parsing the command line, and then the simple behavior of creating a student and printing out its two-string value to standard output. And we validated all of that with the student IT test cases, these integration tests. And we saw along the way, we found some bugs. There were some things that I had missed, in the implementation that none of us caught, as we were doing all that. Did anybody have anything that came up during break that they wanted to discuss about what we've already seen in class?
You go into client.
Oh, excellent question. So, Adam asked, hey, like when you go into a new code base, how do you approach it, especially if you don't see a lot of unit tests? You said clamp it, I mean, sort of like get a hold of it. Yeah. We'll see an example of this when we do the refactoring kata, when we talk about the Gilded Rose kata. So that's, wait a couple more weeks and you'll see it in action. But basically, you do exactly what I think, you're about to suggest. It's like you write some unit tests. You write tests to understand the behavior of the code. This is actually a very powerful and very common thing to do because you want to be able to change it, but you also want to break it. You don't want to break it, but you're not familiar with it, so you don't know really what's supposed to happen. This is another one of the powers of test-driven development, is that over time, because you've got tests, not only can you validate when things are broken, but you also you've codified what the behavior should be. So, step one, or one of the initial steps of approaching a new code base, especially one without without automated tests, is to develop some automated tests, and then give you that feedback as you go and add new features, as you go and fix bugs, what's being done. And now it's the kind of thing that AI can help you with, right? It can look at the code and it can write some tests. Again, good teaching tool for you. Great question.
Yeah, I saw some people that do a big system test. Then, they play
Yep,
around
big,
with it,
yep.
see what the outputs are, lamp for the system test.
Yep.
They make sure they don't break anything.
Yep.
That become-
I don't know how common it is. I know it's a good practice though. Now, of course, there's an upfront investment there, right? You got to pay the cost of, understanding the system enough so you can write tests for it, and then you got to run the test and you figure out how to run the test and if there's all its components, things like that. But, the alternative is kind of flying blind. I would guess that in the long run, having those automated tests, have a great return on investment because they teach you about the code base, they capture the expectations of the code, and then of course, if you do break something inadvertently, then the test will light up red, and you'll know shortly after, as soon as you run the tests, you'll know that you've broken something, as opposed to
you have not done it before.
Yeah, the pitch for TD, yeah, honestly, I've found it's not the executive leadership that objects to it, it's the developers. Because, because, oh, it seems so slow. And you'll be doing it yourself and you'll be like, oh my God, this seems so slow. And it's like, well, yeah, if you're working on a trivial problem, like when we do the code katas and the pairing and the modeling, stuff like that, they're pretty straightforward problems. Um, but it's not one of these, hear me now and believe me later, type things where it's like, yeah, you get, 5 weeks into your project, you'll be like, oh yeah, good. I'm glad I'm still verifying that I can, parse the text file. Or when you, go to project from project 2 to project 3, and you'll see that the format of the command line changes a little bit. Okay, you'll have to go back and, modify your unit test. But once you do, yep, you'll verify that, your tests still keep working. So, I think then, but if there is someone who is not an individual contributor that's skeptical of it, for me, the pitch is you've got automatic validation of quality. Because I'm guessing that, someone who's questioning something like TDD is not trustful of the work of the engineers in the first place. And so it's like, no, this is how, we can demonstrate that the code still works. Great questions. Nice. Okay. Well, let's dive into so you've seen me, write the student test and you've helped me come up with the test cases and we've used we've used Copilot to come up with the test cases, all good stuff. Now let's talk about project one where you're going to be learning about these concepts and actually, well, you'll be applying these concepts to your own work. So project one. So throughout the course, we'll be developing an airline application. So it is a series of Java programs that will be managing an airline, and airlines have flights. We're going to start out really simple, and maybe for some of you, frustratingly simple. I apologize for that, but trust me, it'll get interesting enough, quick enough. And I want to make sure that everybody has a very solid foundation. So, project one is all foundational. What you'll be doing here is creating the first couple of classes for the project, the airline and the flight classes, and you'll be doing command line parsing. And that's really it. So just to tell you right now, you're not going to be writing stuff to a file. Don't worry, that's project two. You're not going to be doing, fancy text formatting. Don't worry, that's project three. And then we'll get to the REST API and we'll get to the Android project. So just, I guess try to savor the fact that the first project seems pretty easy. Students have told me though that, hey, there's a little bit more here, than meets the eye. So you'll be writing some classes of your own. You'll be writing an airline class that extends abstract airline and a flight class that extends abstract flight. Abstract airline and abstract flight are classes that I provide you. They are in a jar that's of code that I wrote. They are in a package called edu pdx joy. Your code, of course, is an edu pdx joy, your login ID. And so you'll have some fundamental classes there. And both the airline and the flight classes must implement all the methods. They are concrete. So there are a couple of abstract methods that you inherit from the abstract classes, and you need to implement them. So a little bit more about the classes that you'll need to write. Airline has a name and consists of multiple flights. A flight departs from a source airport and leaves at a given departure time. The airports are airport codes like PDX, three-letter codes, and they arrive and depart. They depart and arrive at given times. The times and well, both the airport codes and the times are represented as strings for the first assignment. In project three, you'll start working with the local date time class. If you want to start using it now, great, but you don't have to. Everything just can be a string for project one and project two as well. Each flight also has a number, which is an int. And so then, oh yeah, this get departure and get arrival methods, you can ignore them for this project. They'll be relevant for project three. Oh, it looks like, okay, sorry, there's a little duplicate information here. Yeah, but it's got an identifying number. So that is the flight class. And airlines contain multiple flights. We'll be looking at the code here in a little bit. There's also a class called Project One, which is the main class. So this is the main class, and it has a command line. And so what the main method does is it parses the command line, creates an airline, creates a flight from information that's specified on the command line, adds the flight to the airline, and if the optional -print option is there, it'll print the description of the flight to standard output by invoking the flight's toString method. And here is the command line interface for the Project One class. And this is the format that the command lines for projects 1, 2, 3, and kind of project 4 follow. So the command line is it's an executable jar. In this airline, there are some optional options followed by some required arguments. And the required arguments are first the name of the airline, then the flight number, then the three-letter code of the departure airport, the time at which it departs, the three-letter code of the arrival airport, destination airport, and then the time that it arrives. Preceding those arguments may be one or two options. The first one is dash print, which that's the thing that prints the description of the new flight. If dash print isn't specified, actually there's no output of your program. That's the way it works for project 1. It'll get more interesting in project 2. There's also something called a dash readme option, and I'll talk more about that in a little bit. And the dates should be the format, 2-digit month, 2-digit year. Well, actually, 1 or 2-digit month, 2-digit days, 4-digit years, and then 24-hour time, hours and minutes. Oh yeah, something important. So like the airline, if there's a multi-word airline, put that in double quotes. But note that the times are each two command line arguments. So like the time is one command line argument is the date, the other command line argument is the time. And I think do I have an example here? I don't have an example. I really should. Sorry. Yeah. So that's the format of the command line. Um, Before I start talking about the code, uh, are there any immediate questions or uncertainties or something you'd like me to clarify about the command line interface for the project, or just the requirements that you've seen so far about the project? Mhm. Nice. Thanks for the thumbs up, Jasmine. Um, okay. So I'll come back to that later. Yeah, let's create the project. Okay. So just like creating the Koans project, or we saw creating the student project, you do so from the PSU machines. So I am going to log into the PSU machines. I am going to go to my checkout, Joy of Coding Summer 2026. I'm going to do a git pull. I don't remember if there's anything that I need to get here. Oh, there were some changes. Good to know. Right, of course. Yeah, we were just doing the project. Okay, so I'm going to run the create first project script. Okay, that appeared to be successful. And now I have a modification to pom.xml, which I think is going to be the addition of that project. Yep, here under my modules now, I've got koans, I've got student, and now I've got airline. And there's an airline directory. So I'm going to add both of those to Git so that I can commit them and push them. As you can see, there's a whole bunch of code that gets created there for the flight project, some of which I'll walk through it in a little bit. I'm going to commit that now. Actually, I'm going to make sure that it builds first. So I'm going to do a Maven W. I shouldn't need to do a clean, but I will verify. Make sure all that builds. Pretty good so far. Yep, that was good. Okay, awesome. So let's commit added airline project. We'll push that up. Nice. That's everything I need from the PSU machines. I'm going to log out. Now back over here, I am going to update my project. I'm going to say, where's update? Come on, babies. There it is, update project. Gonna merge changes in. And over here, done with student for a little bit. And now I have airline. It detected airline as a project. So I've got some code. Now, airline looks a lot like the student project in that it's got several flavors of code. It's got integration tests. It's got the main code, and it's got test code. Tests or unit tests. Integration ID or integration tests. There's some things in here, including this XML helper, which when I use this project in the summer, there's an XML. Um, yeah, there's been an XML unit. We don't do that. We don't cover XML in the summer course, so you can ignore this. And if it gives you any problems, you can just delete it without any issue. But it's got some it's got it's got some skeleton code to get you started. It's got project one, it's got airline, it's got flight. Let's just take a quick tour through this stuff. Here's airline. Airline extends abstract airline. And it's got methods like, well, every airline has a name. You create with a constructor, and you can add a flight, and then you can get a flight. Out of the box, they're not supported. It's up to you to figure out how to support this stuff. Flight, as I said, it has a number, a source, a departure string, a destination, and an arrival string. Again, all this is unimplemented. It's up to you to implement all this stuff. And then accompanying this, oh, and for project one and two, you can ignore, actually, no, project one, you can ignore the text dumper and text parser. We'll be seeing that in project two. But accompanying the project one, the airline flight, are some tests and some unit tests. So there is a test for flight that these are actually, most of these will get updated or deleted. So for instance, it's like, hey, this asserts that, yep, get arrival string needs to be implemented. Well, once you change get arrival string to do something other than throw an exception, then this test becomes useless. So let's delete that and start over again. However, I did want to have some tests to give you examples of things like, here's how to do an assert that, and here's how to do an assert throws. Um, but again, yeah, you'll likely need to delete this stuff um, as you implement your code. There's also a project one integration test, which is just like the integration test that we've been talking about so far in class. And again, to sort of get you started writing some unit tests, integration tests. Out of the box, all these pass. But as you develop your code, again, you'll have to modify some of them. They might fail temporarily as you're getting them to work. It's all part of the project, right? Making sure that all of your tests run. Oh, there's some other things like resources, and we'll talk about that at a later time. Actually, do we? Sorry, I want to make sure when we talk about that. No, we might talk about it tonight, or we might save that until um, Monday, depending on how we're doing on time. We got 20 minutes left. I don't know if we're going to get to it tonight. So, bottom line is that you can run these tests just like any other tests. Things pass. Here on the command line, we now have our airline as part of our checkout, and we can run Maven W clean verify. That'll run the entire project. It'll build the source code. It'll run the unit tests. It'll create the jar file, run the integration tests. Great, all stuff like that. Things are nice and green. And so there's your code. Anybody playing along at home? If so, have you encountered anything surprising or unexpected as you've been working with stuff? If you haven't, that's fine. Turn to the assignment. So again, here's a description of the code. Oh yeah, here's how to run it. Just like with the student program, we've got an executable jar file. So you say java-jar target, in this case, airline 1.0. It prints out what the main method, it runs the main method, which is missing airline information, which if we then go to project one, we go to the project one class and we look at the main method, it just prints out missing airline information. Oh, and it also goes through and prints out, it iterates over each argument. So if I said, 1, 2, 3, it prints out missing airline information and a 1, 2, and a 3. This is a little example of, using a class. Okay, so that's the code. I want to talk a little bit more about the behavior of it. So as I mentioned earlier in class tonight, project one, and just like the command line projects specifically, are about providing a good user experience. And the way you provide good user experience for command line tool is that you output meaningful text to the user. And a lot of that is error messages that are user friendly, that make sense and are actionable. So, for instance, issue a message and exit gracefully if something's missing from the command line, or there are too many or not enough arguments on the command line. Note that because of the options, any command line argument that starts with a dash that appears before the first program argument, which is in this case the airline name, that's considered an option, right? So then, let's see here. Let's just put together an example here on the command line. It would be like, Air Dave, and then that's the name of the airline. Flight number is 123. The source is PDX, and let's say it departs, tonight at well, like 8 p.m. and then arrives at LAX at let's see here, tomorrow maybe the middle of the morning at 12:30 a.m. or something like that. So that's a valid command line right there. If you wanted to have an option, all options go before here. So you say, dash print before this. And then if you had like a bogus argument, so like, whatever, dash bogus, it would appear here. And so then you should interpret this as an option, not as the name of the airline. And so then for an input like this, I would expect the program to issue an error message saying, unknown option dash bogus. Also, issue a friendly error message if the format of the day or time is incorrect, or well, not the description is empty, but like the name of a destination or something like that is empty. For project one, you don't need to be you should check to make sure the syntax of the date and time is correct. And don't issue a warning. Just like fail. It's okay. Don't try to guess what the user is trying to do. Be explicit in your error checking. Note that you don't need to check the semantics of the date time. So I'm not going to test with it, but you can accept input like February 30th, not a real date, but don't bother trying to be fancy there. Also, if oh, interesting. Or if the flight number is non-numeric, or the airport code doesn't contain 3 letters, right? Just some error checking like that. And again, don't want to see exception stack traces. An error message like, missing destination airport will receive more credit than like missing command line argument. Not nearly as actionable. And again, issue a helpful error message like listing what the command line arguments are when no arguments are provided. Now, I do have some notes about like what my expectations are and how it's graded, things like that. So, I acknowledge that this functionality is pretty simple. You're parsing the command line, you're putting together some objects in memory, you're invoking a two-string method. And just to be clear, there's no writing to a file. You don't read from standard input, nothing like that. This is easy, or this is simple. As a result, there isn't much like happy path testing for me to do. Really, there's like only one command line that is valid and has output, which is a properly described flight and the dash print option. So most of the test cases will have invalid input. And really, yeah, for project one, what I'm evaluating is how well your program responds to bad inputs. Is information specific? Is it actionable? Is it something that the user can understand and act on? Granted, a lot of this is kind of subjective. But please, think critically about the output that you provide. And of course, if you have any questions about what makes for ineffective or effective output, want to run anything by me, please, DM me, or actually, go ahead and ask about it in the class channel. I'll be more than happy to engage in it. Um, I'll talk about submitting next time, but use the submit script with project one. We'll go into more details about that um, next time, and you can also read about it in the README. We've already created it. We've already seen how to run it. And then just a couple more notes about how it's graded. So a couple years ago, some students came to me and said, "Wow, your expectations are very different from what I'm used to in other classes." I'm like, "Really? Say more." And so they did. Um, they said that there are some courses where they like give you all the test cases ahead of time and they're like, go make a pass. And then other times where the output seems to be much more subjective, or it's like, oh, you're graded on the internal quality of the code as opposed to really what it does. And then they sort of said, well, your class is kind of in the middle, where yeah, you don't tell us exactly what the input, you don't give us exact test cases. You give us this document, we've got to interpret all of that. But then you definitely have test cases in mind because you were testing script and that's what we're evaluated on. And I'm like, yeah, that's how it works in this class. These are important skills to learn, right? To be able to take a spec that is expressed by a human in some attempted English, and then to write real code based on it. And so then part of what is that you learn in this class is how to interpret, how to ask questions, how to get feedback, take feedback on your projects. So, and also, anybody who wants like a rubric with like exact capabilities of testing and how much, no, I'm sorry, I don't do that. It seems to me that either gives too much stuff away or then just gives people an excuse to test, to focus on some things and not others. Nope. And you'll figure it out pretty quickly. And also, like, as I talked about on the first day, like if there's something completely wrong with your program or you've missed an important requirement, yep, you have an opportunity to resubmit it. And it's all learning, right? Because what we're here to do is learn, not just like go from A to Z, but to figure out, how to start at A and go someplace interesting. Um, and I do want to note that my testing, the test cases that I use for project one, you'll see a number of those again in project two, project three, et cetera, et cetera. So there's a lot of words here, and I went through them kind of quickly, but is there anything else I can tell you about project one, about the expectations, about how to approach it, about what you need to do to get started and implement it? Great question, Ala. Regarding Canvas, what's the difference between the Project One and the Project One POA submissions? I will get to that shortly. POA is something called a plan of attack and has to do with documenting your code. Oh yeah, that's a good point. Uh, the project itself is worth 6 points, 5 points for the code, and 1 point for the plan of attack, the POA.
We're gonna karate chop it.
Karate chop. That's yes, I have a plan attack. Yeah, no. Karate chop. I'm no Mr. Miyagi. No, I'm not even like Danielson on a good day. Oh my God. I will go watch some Cobra Kai. Anyway, um, they made a TV show about my midlife crisis. I mean, it was amazing. Anyway, sorry, men of a certain age. Okay. So awesome. So that's project one. I know you're still working on the koans. I encourage you to, find a few minutes to get started on this. Make sure that that you can create the project, that you can build it at least. Keep this stuff in mind, and actually read over it and start thinking about it as you do in your koans. You might pick up on certain things like, oh yeah, how do I use that array list thing? And oh yeah, what is override? How do I override methods and things like that. The intent is that the koans that prepare you well for project one. Okay. Um, Testing your projects. Okay. So, as we've seen this week, testing is an important part of what we do here in the Joy of Coding. And for several years, I told students, yeah, go ahead and I'll write tests. And, please do that. Please do that. And I'm like, is anybody actually doing that? And I'm like, I'm not too sure they are. So, but basically, long story short, I think we've already talked about like why we should test. And now, well, I want you to test. So, and the way I'm going to assess how much you've tested is I'm going to measure the code coverage of your automated tests. So, as you write tests, your tests invoke certain pieces of code, and any code that doesn't have a test associated with it hasn't been tested. And so, how do you know it really works? And so to force you to write tests for your code, up to one point of your grade is based on your code coverage. And so my expectation is that your automated tests, both unit tests and integration tests, cover at least 75% of the JVM instructions in your code. And so we use a tool called Jacoco for Java code coverage to measure this, and here's how I do that. So I'm gonna run Maven Clean Verify, but I'm going to run it with a dash p grader, which runs something called a Maven profile for the grader. And what this does is it doesn't clean verify. It blows away all the artifacts. It goes and runs all your tests, and at the end, it tabulates how much of your code has been covered by your unit tests. And if less than 75% has been covered, then the build fails, which is what happened here. So it said that only 66% of the instructions were covered. So this is the lines of code essentially covered. And the minimum is 75. So out of the box, there's not sufficient code coverage. Okay. Um, so this is good to know, but then the natural question arises, oh, how do I find out like what code isn't being covered? And so then when you run the Jacoco code coverage, it generates a report in the target site Jacoco index.html file, which then I can open site Jacoco index.html, make it a little bigger. That tells you that lets you see how much code is covered. So as we can see, we look at missed instructions here, and 66% have been covered, and you can drill in. Here are the classes in the project. And as you can see, text dumper and XML helper, well, they're nicely covered. Your text parser isn't. But flight and project one aren't. So project one only has 56% of lines covered. And so you can drill in here, and you can look for each method, but then you can finally bottom out, you can see all of the code. And so you can see that like this is valid date and time is not covered. And so there's not a test for that. Nor is there a test for this for inside this loop here. And bottom line is though is that as you write more code and write more tests, you need to keep the code coverage in line. If you do test-driven development, you'll achieve almost 100% code coverage, at least you should, because again with TDD, the only code that you write is in service of making a test pass. And so then if you do that, then you'll just naturally have high code coverage because you've always got your code is always covered by a test because you wrote the test first. Yeah, this also talks a little bit about the main test case we've already talked about tonight. Other than that, yeah. Talks about integration tests and some properties thereof. Please read this in detail. Oh, important thing to note here. Okay. Um, in this class, do not invoke system.exit. uh like as you'll notice, like when I wrote the main method for the student class, I returned from the main method. I did not invoke system.exit. If you invoke system.exit in your code, sorry, if while running a test system.exit is invoked, the JUnit test harness is confused because it's like, well, I had 10 tests to wrote, and after the fourth one, the JVM exited. Something's going on here. And so you'll see, messages like process finished with exit code, or like when you run from Maven, you'll get things saying, listen, I ran your test in a VM. It didn't, it crashed or was, system exit dot called and things like that. So if you see these kinds of error messages, it may mean that you invoke system.exit. And I think that's what I wanted to cover with testing. Please read over this document because I think there might, because it'll help reinforce what we talked about tonight. But the bottom line is that tests are required for this course, and the way that is evaluated, the ways that is assessed, is by looking at the coverage of your tests. Anything else I can tell you about that? Anything else you'd like to know about the code coverage requirements?
Code coverage calculated just by volume, by quantity.
Well, the way it's calculated is that Jacoco actually keeps track of, you can think of it as it's got this little clipboard. It's got the source code printed on its clipboard. And as the tests are run, it's like, okay, that line of code was run, that line of code was run, that line of code was run. So it's, I don't know if I would exactly say that it's, well, instructions, technically, you can think of it as lines. Yeah. In that way, we got like some, big hairy line. Well, yeah, actually I don't even know if Jacoco really works at lines because remember Jacoco works on the bytecode itself, so it doesn't know what corresponds to a line exactly, or else he doesn't go to the effort of trying to figure out what's a line of code versus what is an instruction. Nice. Okay, we got a couple more minutes. Um, let's take the time to talk about how to document your projects because we did ask about the plan of attack. Okay. So testing is important in this course, as is documentation, as is communicating about your code in human language. So, and this is something that you see all the time in the real world. You have to describe what you're doing beforehand. You need to tell people what you did afterwards in your pull requests, in your conversations, your exchanges with your coworkers. When you look at someone else's code, you benefit from whatever documentation that they wrote. So there are a couple of, and I want you to get experience with this. And so there are a couple of methods of documenting in this class. The first is called a plan of attack. So you don't need to do it for the koans, but for project one and all the projects in your airline, you are I asked you, you're required to submit what I call a plan of attack for each project. It's basically a couple of paragraphs about the design of your project, and it's meant to be authored before you start writing code in earnest. Really, what this does is it demonstrates to me that you've thought about and done a little bit of planning for your project before jumping in. Um, please send it to me as a plain text email. Don't put it in a PDF document. Don't send me a link to a Word, or a Google Doc or anything like that. Text in an email. It'll be all right. And don't send me code. I want to see words. And all POAs are worth 1 point of the project grade. Plan of attack POAs should be emailed to me at whitlock@cs.pdx.edu. No later than 72 hours, 3 days before the project is due. So the project is due on Wednesday. This means by Sunday at 6 p.m., please submit your POA. While I'm flexible on your regrading projects, and okay, it's okay to be, late a couple of times. I don't accept late POAs. This really is a forcing function to make sure that you don't start things at the last minute. I'll be clear on that. When you send me the email, please make sure to put the letters POA in the subject because everything then gets routed to its own folder. That also means if you've got some important email for me, don't put POA in the subject because I'm likely not to see it until I grade the POAs. So that's what the plan of attack is, as Yasmin noticed on the assignment. Anything I can clarify with you about the POAs? Um, I'm just going to quickly go through this, then we can go into more detail next. Actually, we're out of time. So anyway, I'll finish this up at the beginning of class on Monday. Of course, you feel free to read ahead. But I also have requirements around API documentation for the code that you write. So java.comments and the README, which is essentially more than command line usage, a paragraph or so about what your program does and how it does it, and then this is actually something the program prints out. And we'll see next time how you can use something called the resource API in Java to read the contents of a README from a file and then print it out. But we are at the end of the class, and I want to respect your time. I know it's been a long evening for everybody. Thank you for joining, though. I appreciate the attendance and engagement. And I look forward to seeing you next week, where we will dive into pair programming. Have a good one, everybody. Happy Independence Day. Have a fun and safe long weekend. Bye now.